This is the more substantive piece of the material this week. Um, we're going to go over correlation and regression. I'm not sure which one. I assume Rick will start with correlation probably this Wednesday, and then um, homework 5 is not going to be due until November 1st, so 2 weeks out. So then the following week, I'm sure he'll get to the bivariate regression. So, this is again going to be a situation where you don't have the background substantive knowledge about correlation and regression, but we'll work through the functions really quick on how to do that, and just not really get stuck on interpretation. So again, we just need the library for Rio because we're going to be importing data, and we don't need any special packages. Everything that we're going to be doing is just going to be in base R. So when we have two continuous variables, we can find a measure of their correlation, and this measure describes the size and direction of their relationship. Researchers frequently treat variables on a 7-point scale as continuous variables in their analysis, which is why we created the 7-point party ID variable, or why we're going to ask you to do that on homework 5, and also why we've got the conservative variable, why we left that as numeric and have that on a 7-point scale. It's just more useful for running analyses. Since you haven't actually done the party ID variable yet, I'm going to use the conservative variable in our data set for these examples. And we'll start with the correlation function, which is, and this is actually just one R in here. So the function to find the measure of a correlation in R is COR, and takes the format of core, open parenthesis, x, comma, y, comma, use complete observations. This is really important because if you don't include that, it's going to throw an error of some sort because of your NAs that you have in your data set. And then the next argument is method, and you don't have to include all of these. I don't think. Just the example that I found had them all in there, so I figured we might as well just throw them all in there. So what that's going to look like with our data, I used the conservative variable, like I said, and you do for this want to include the entire my data $conservative, my data $. I use the socialist feeling thermometer here, and then the rest of it I just copied and pasted from above. And if you run that, oh hey, what is going? Oh yeah, didn't catch both lines here. Okay, it just spits out this number for you, which is your negative. It's a negative correlation, so you know that like the correlation line is going to trend downwards. Correlations, the measure is typically between -1 and 1. So we've got -0.66, which is relatively high for correlation, or inverse correlation in this case. There's also a function core.test that's going to return that same measure, but also give you a p-value and a confidence interval that takes just the same exact format. It's just core.test is the function instead of just COR. So for this one, it's actually going to give you t-value, t-statistic, the degrees of freedom, and a p-value, as well as a 95% confidence interval. And then it gives you the correlation that we saw in just the basic function. The other thing that we're going to be getting to in the next couple of weeks is just a simple bivariate regression. So the ANOVAs are used to find the difference in mean of category variables. where regression is a statistical method to establish the relationship between sets of variables in order to make predictions of the dependent variable with the help of continuous independent variables. The regression function in R is LM, which I mentioned last week in class, and as I also mentioned, it takes a similar format to the ANOVA format, and really the t-test also used this format for one method of running a t-test, and that is LM, open parentheses, your dependent variable, the tilde, and then your independent variable, comma, data equals whatever your data frame is. So in this case, my data. We want to actually assign this function to an object name because if you run it alone, if you just look at this, it's going to give you the regression coefficients, but nothing else. So if you assign it to an object, we're going to call it M1 for model 1, and then run a summary, then it's going to give you all of the good stuff that you want out of a regression. So it's going to tell you all of this information about the residuals, which Rick, I'm sure we'll talk about in a couple weeks. It's going to give you the regression coefficients that we saw in just that simple when we just ran the function by itself. But it's also going to give us a standard error and a t-value or t-stat and a p-value. So we know that it's significant. Note that this t-statistic is the same as when we did this correlation up here, and I'm sure Rick will elaborate on exactly why that is when he does his lecture on one or the other, probably when we get to regression in a couple of weeks. So that is it. Like I said, these are going to get very simple as far as like adding extra steps to do the different analyses. Really the hardest part is deciding which type of analysis to run and cleaning your data in the first place.